Let's take the derivative of x to the x power. The key to doing this derivative is to use a property that x is equal to e to the natural log of x. So whatever is here will end up being here. So x to the x will then just be e to the natural log of x raised to the x power. So I'm going to rewrite x to the x as e to the natural log of x raised to the x power. And for the derivative, I need to multiply by the derivative of the exponent. So here, if I'm taking the derivative of this, I want to take the derivative of the exponent, which is natural log of x raised to the x power. We know that if I have natural log of x to the nth power, I can bring out the exponent in front and leave the rest the same. So what I'm going to do is bring the x in front of the natural log. So this would just be e to the natural log of x to the x power times the derivative of x times natural log of x. I'm going to use product rule now for x to the ln of x. We know the product rule is f prime g plus g prime f. So now that's going to look like, well, the derivative of x is 1 times natural log of x, plus the derivative of natural log of x is 1 over x times x. So this simplifies to e to the natural log of x to the x times ln of x plus 1. We know that e to the natural log of x to the x is equal to x to the x from here. So that is our derivative. Let's now look at x to the x power. So we're going to add another layer of x. The process is the same. So we're going to rewrite this as ln of x to the x to the x. Okay. And then I'm going to take the derivative of ln of x to the x to the x. Okay. So let's rewrite this now. So this will just be the same. And then I can rewrite this as these guys coming out in front, like this. Because x to the x, those are the two exponents. Okay, so the exponent comes out in front of the natural log. And if I want now, I could just say, okay, e to the natural log of x to the x to the x is the same thing as x to the x to the x. Now I need to do the product rule. So I'm going to take the derivative of x to the x. Good thing we just did it. So we're going to use the result that the derivative of x to the x is x to the x times ln of x plus 1. Okay, so this thing is the derivative of x to the x. And then times natural log of x plus the derivative of natural log of x is 1 over x times x to the x. Okay, let's see, I can distribute this natural log to both of these, and I can simplify 1 over x times x to the x. Okay, so I have x to the x to the x times x to the x times the quantity ln squared of x plus ln of x. I just want to be clear here that the square is on the ln, not the x. So I cannot bring it out in front. Okay, plus, so they both have the same base. I'm going to subtract the exponent. So that's going to be minus 1. I see what they both have in common in both terms. So They both have a base x, so you always choose a smaller exponent. So in this case, it would just be the x minus 1 exponent. So we're going to multiply that to x to the x to the x. So the only thing here is I have to multiply by x. So that would just be times ln squared of x plus ln of x plus 1. Okay, let's work with these guys. So they both have the same base x. The exponent here is x to the x. This exponent is x minus 1. Whenever you're given the same base and you're multiplying the two, you always add the exponents. So add these exponents. So then you get x ln squared x plus ln of x plus 1. And here, if you want, you can distribute out the x to both ln squared and ln if you want. So if you can just say, okay, that's just x ln squared of x plus x ln of x plus 1. Okay. And that is your derivative of x to the x to the x. Okay. All right. Next, we're going to be looking at finding three derivatives. So, sorry, finding three x's as the exponent. Okay, what if you have x to the x to the x to the x? So this craziness. Okay, well, we're going to rewrite this as e to the natural log of x to the x to the x to the x multiplied by the derivative of the exponent, which is ln of x to the x to the x to the x. Keep in mind here, the exponent are these three pieces. Okay. So I'm going to rewrite this. I know e to the natural log will just cancel, so I'm just going to have the x's like that. I'm going to rewrite the derivative. So I'm going to rewrite first the inside the parentheses. The exponent is going to come out in front. And then I'm going to multiply that by ln of x. Okay, now I'm going to use a product rule. So I'm going to first take the derivative of x to the x to the x. So using the previous results, we know that it's x to the x to the x plus x minus 1, okay, times x times ln squared x plus x ln of x plus 1. Okay, this whole thing is just a derivative of x to the x to the x. So let me just make a note of that. Times, oh wait, sorry, this whole thing, times ln of x plus the derivative of ln of x is 1 over x times x to the x to the x. Okay. Let's see. I can distribute out the ln of x to all of these. Okay, let's just do that. So ln squared times ln of x is ln cubed. And we can simplify the 1 over x times x to the x to the x. We're just going to subtract the exponent. So that's minus 1. Okay, all right, now the hard part is understanding what we have to factor. Well, if you look at these two terms, you look at the x here as the base. So you find out what is the smaller exponent. Okay, so is x to the x plus x minus 1 smaller than or bigger than x to the x minus 1? Well, it's pretty obvious it's bigger because you have an extra x here. Okay. So we're going to factor out the smaller one. So that would just be x to the x minus 1. What remains, we said, is the x to the x times, well, times x, well, yeah, times x ln cubed plus x ln squared plus ln of x and plus 1. Okay, and notice that they have the same base, so you just add the exponents. So we're going to add these. And then we're just going to leave whatever's inside the same. So x ln cubed plus x ln squared plus ln of x plus 1. And this is the final derivative.